Good morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelius Lubinda with another video. And in this video, we are going to continue on the additional mathematics, paper 1, 2024. This one was the GCE. Alright, this is the part 2, of course. Take note, the time duration for this paper is supposed to be 2 hours, but these videos are aimed at explaining. So as you are practicing, take into consideration that you need to put into consideration the aspect of time management. Okay, so this was how the paper was looking. We are answering question 6 to 10. Question 6, which is prove the identity sin theta squared minus 1 plus tan theta squared times cos theta squared divided by sin theta cos theta is equivalent. So this there is supposed to be equivalent, though it's not that clear. Is equivalent to negative cos theta. Okay, so let's start by writing sin theta squared minus 1 plus tan theta squared in brackets. So let's write that down. So this is question 6, where we have sin theta squared minus 1 plus tan theta squared, like that. And then outside the brackets, we have cos theta squared divided by sin theta cos theta. So outside the bracket we have cos theta squared divided by sin theta cos theta is equivalent to negative cos, let me just confirm, is equivalent to negative cos theta, like that. So sin theta cos theta, like that. We have confirmed. That's how the question was written. So this is how it is. How do we proceed? We choose which side of the identity that way is the most favorable. So we go for the left hand side, and then we'll say is sorry for that, the page just was trying to save itself. So left hand side, let me just try to bring it back. Okay, is equal to, we have sin theta squared minus a1 plus tan theta squared, like that, cos theta squared, you divide by a sin theta cos theta, like that. So how do you proceed from here? As you can see, what is inside the parentheses of the brackets there is 1 plus tan theta squared, and it's an identity that we need to know. It's what? It's the same as sec theta squared. So we will say is equal to sin theta squared minus, in bracket, sec theta squared is the same as 1 divided by cos theta squared. Okay, so cos theta squared, let me try to write the squared properly. Okay, something like that. Then multiply by cos theta squared, then everything is divided by sin theta cos theta. To continue, you can see that the cos theta squared can cancel out, where you just remain with is equal to sin theta squared divided by sin theta cos theta. And then here again, sin theta can go into itself a 1. As you can see there, it can also go into a sin theta. How many times? I hope you have followed there. Okay, just seen something I didn't see. Sorry for that. I didn't take notes properly. It's supposed to be actually equal to a sin theta squared minus, since there we have cancelled out, we remain with a 1. I've got to say minus 1. Then you divide by a sin theta and then a cos theta. Okay, if you look at this nicely, we need to think of a way of factoring, of remaining with something having cos theta squared, because if you look at the left hand side of the equation here, you only have cos theta there, so we need to think of a way of eliminating the sine theta squared, where we can just remain with the cos theta in a way. So here, if you look at it, we can say is equal to, what identity is this? So sine theta squared is the same as 1 minus cos theta squared, okay, then minus 1 divided by sine theta cos theta. And as you can see here, the positive 1 and the minus 1 will cancel out, leaving you with only a negative cos theta squared. Then you divide by a sine theta cos theta. And then cos theta can go into itself a 1. Into that, it's just cos theta. And take note there's a negative there. So it's going to be equal to a negative cos theta divided by a sine theta. And this is the inverse of tan theta is equal to sine theta over cos theta. And we know inverse trig functions will give us what? Will give us the inverse of tan is cotangent theta. So here there's actually supposed to be equal to negative cotangent theta, but on your right hand side you had negative cos theta. So this past year question is a past paper which is known that it gave an answer that is not proven. So how do you conclude? You will say therefore left hand side is not equal to right hand side. This identity, let me just reduce the handwriting, therefore left hand side is not equal to right hand side, so you write it like that. This identity cannot be proven. Simple as you like that. Then to continue, we are going to go to the question. Okay, so now we are going to continue where they are saying find the middle term in the expansion of x squared plus 2 divided by x raised to the power 8. This is carrying 4 marks. So how do you know the middle term of such an expansion? For us to know the terms, we should know that terms begin from, for example, n choose 0. In this case, it is power 8, so 8, you choose 0. Now, if the power, for example, in this case, 8 is even, you just have to divide it by a 2, and that would be your term, that would be your middle term. Or if you want, you can count with me. So you have 0, 1, 2, 3, 4, 5, 6, 7, 8. If you count properly, there are 9 terms. So you can see that the first 4 terms, which is 0 to 3, 0 to 3, I hope you can see that. Those are the first 4 terms. And then 6, 7, 0 to 3, and then the fourth one, okay, will be the middle term. Then 5, 6, 7, 8 are the last 4 terms. So it means that the fourth term, fourth one, or let me not say the fourth term. 0, 1, 2, 3. Because you can have, for example, 0, okay, which is a choose 0, a choose 1, a choose 2, a choose 3, which is the fourth term. So the fifth term, okay, so when you divide by 2, you add 1. That's the middle term. That is for even powers. Divide by 2, you add 1. That's the shortcut method. I hope you understood what I did, because the first 4 terms, which was n choose 0, n choose 1, n choose 2, n choose 3, will give you that. Now, n choose 4 will give you the middle term. So to know the middle term, it will be 8 choose 4, but 8 choose 4, okay, is actually the fifth term. Okay, I hope that's clear. So x squared plus 2 over x to the power 8. I also need to bring out that explanation. I believe that's 7a. X squared plus 2 over x to the power 8. I hope that's how it is. X squared plus 2 over x to the power 8. And you want to find the middle term of that. There's no need to expand, because that would be time consuming. So it will be 8, you choose 8 choose 4, x to the power 8 minus 4, and then 2 over x to the power r is 4. So it will become, on your calculator, 8 choose 4 is 70. So it's going to be equal to 70 times 8 minus 4 is x to the power 4 times, here you're going to have 2, okay, the power 4 is 16, and the next to the power 4 is just like that. So 16 divided by x to the power 4. So in this case, it's kind of a coincidence that the middle term is the term independent of x, where the terms are cancelling out like that. So I'm going to have 70 times 16, which is giving you 1120. Therefore, middle term is equal to 1120 as your final answer. I hope you got what I did here. So I said that if you want to know the term, okay, if you want to know the binomial, just do 8 divided by 2 is a 4. So it means 8 choose 4 will be your middle term. But if you want to know, with the binomial to give you the middle term. But if you want to know the middle term, it will be 8 divided by 2, giving you a 4, plus 5, plus 1, which is going to give you a 5. That's your middle term. That's what you can use. But the binomial is 8 choose 4. Alright. Well, this is the fifth term. And then you use that type, particular kind of, oh no, here those x squared, actually I didn't take note of that. So x squared to the power 4, index of an index, so take note, sorry for that mistake, didn't see that one. So x squared to the power 4, index of an index just means 2 times 4, so x to the power 8 times 16 over x to the power 4, where this and this will give us x to the power 4. So the middle term was actually supposed to be like that. Just take note, it was my bad. I didn't take note of the indices there, because index of an index right there will give us squared times 4, which is 8, cancelling out like that. Okay, So let's go back to the question. That was A. Then B, the coefficients of x and x squared in the expansion of 1 plus qx multiplied by 1 plus px to the power 6 are 0 and negative 21 respectively. Given that P is greater than 0 and Q is less than 0, find the value of P and Q. This is carrying 5 marks. So 1 plus qx, then 1 plus px, the power 6. This is our 7b. 7b. So 1 plus qx multiplied by a 1 plus px to the power 6, like that. I hope you can see that. So 1 plus qx then 1 plus px to the power 6. Then we are concentrating on the coefficients of x and x squared, so we should go as high as the x squared term, and then coefficient of x is 0, coefficient of x squared is negative 21. We can also write that down for reference. So we have the coefficient of x is 0, x squared it is let me try to confirm if it's negative 21. Negative 21, yes. So x squared is negative 21, like that. Then you just expand nicely. So you get to 1 plus px raised to the 6. Then 6 combination of 0. And then 1 to the power 6. Okay, I'll just write out everything. 1 to the power 6 minus 0, then px to the power 0. Usually I don't need to write this. Usually I don't need to write this one, but we'll just write it. Plus 6 combination 1, then 1 to the power 6 minus 1, then px to the power 1 plus 6 combination 2, then a 1 to the power 6 minus 2, px to the power 2. The binomial keeps on going until we reach this power 2 becomes what? A power 6, which is the nth power there. Okay, but we're not supposed to go that far, so we'll say and so on. Alright, 6 combination 0. How many times can you choose 0 items? There's only one time. So 0 plus, so here we have 6 multiplied by px. So we're going to have is equal to 1 plus 6px, like that. And then 6 combination 2, 6 choose 2 is a 15. So plus 15 plus a 15, and then p squared x squared. So that's your expansion as far as the term of x squared. And then you add 1 plus qx multiplied by a 1 plus 6px plus 15p squared x squared, like that. Then we say is equal to we have a what multiply to give us something having x. So this 1 times 6px will have a 6px, and then we have this qx times a 1 will have plus qx, and then we have this same 1 again times, in this case, a 15p squared x squared, so it will have a 15p squared x squared, and then this qx right here times a 6px right over there. You are going to have a positive 6p qx squared, and those are the possibilities. And then we just group everything up in x. Okay, well, we'll have 6px plus qx is equal to 0x. So we can drop x, well, we'll have 6p plus q is equal to 0 as our equation 1. And then we'll also have a 15p squared x squared, as we can see up there, then plus 6p q x squared, you can see that, and then we'll say is equal to negative 21 x squared. Well, we'll drop x squared, then we'll just remain with 15p squared plus 6p q is equal to negative 21. So here you have a combination of 6p q. And then we can see that here q is that. So we can just say let q be equal to something in this equation because we have a 6 like that. So we'll just proceed like that. We'll say let q be equal to negative 6p in equation 2. Okay, so negative 6p in equation 2. So we have 15, I haven't written that 5 properly, 15p squared, and then plus 6p, q is a negative 6p, like that, is equal to negative 21. Then doing your mathematics, you're going to have 15p squared, and then 6p, negative 6p times positive 6p, you're going to have negative 36p squared is equal to negative 21. Okay, before I even proceed, here we know that there's a number that can go into all of this, and that number is 3. Sorry for that, document was trying to save itself. That number is 3, so divide by 3, divide by 3 throughout. You're going to have 5p squared is equal minus 12p is equal to negative 7. Minus 12p squared, take note, is equal to negative 7. And then here, if you do your mathematics properly, you're just going to remain with a negative 7p squared is equal to negative 7. Divide by negative 7, divide by negative 7, like that, like that. P squared is equal to a positive 1. Apply the square root, apply the square root. P is equal to plus or minus c. Square root of 1 is just 1. But the examiner knew that you would find such a solution, so they restricted you that p should be greater than 0. So you say p is equal to 1. You even underline it. Then you say p is equal to negative 1 is invalid. Yeah. And then you continue. You let p be equal to 1 in equation 1. So you say when p is equal to 1 in equation 1, so you have q is equal to negative 6 multiplied by p, which is a 1. Q is equal to negative 6. Therefore, p is equal to therefore P is equal to 1, Q is equal to a negative 6. And if you look at the conditions, okay, look at the conditions for the question. Let's try to see the conditions for the question. They said Q has to be less than 0 and P has to be greater than 0. So as we can see from our solutions, Q is less than 0, P is greater than 0, and therefore the solutions are valid. And then we go to question 8. Question 8 is a question on calculus. So it reads, find dy dx for the equation y is equal to x plus 2 divided by x squared plus 1. This is carrying 3 x. So x plus 2, y is equal to x plus 2 divided by x squared plus a1. I don't think that page had enough space, so go to the next page. So we are saying that this is question 8a. Y is equal to x plus 2 divided by x squared plus a1. Let's confirm. As you can see there, x plus 2 divided by x squared plus a1, and our page is right here. We start by saying let u be equal to the top function, which is x plus 2, and then v be equal to the bottom function, which is x squared plus 1. We differentiate the functions separately. Du dx is equal to 1, and then dv dx is equal to 2x. So you have a 1, you have a 2x. Then we remember the product rule, which is dy x, like that, is equal to v. You start with v du dx minus u dv dx, everything divided by what? V squared. So this will be equal to v. Your v is x squared plus 1. So x squared plus 1 times your du dx, the positive 1. So this times positive 1 minus, you have your u. Your u is x plus 2. Your dv dx is a 2x. So you're going to have x plus 2 multiplied by a 2x, like that. Everything we can put it in square brackets, divide by v, and then that v is x squared plus 1, which has to be quantity squared. So we have x plus 2 multiplied by 2x, just like that. And then to continue, you're going to say is equal to x squared plus 1 minus, in those square brackets we can simplify it to become 2x squared plus 4x, like that. So 2x squared plus 4x divided by v squared, which is x squared plus 1 squared. Okay, we can now start simplifying. Is equal to x squared plus 1 minus 2x squared minus 4x. That is distributing the negative inside the parentheses. So here you group like them together. So x squared plus a1 quantity squared. So it's going to become what? It's going to become is equal to negative x squared minus 4x plus a1 divided by x squared plus a1, which has to be squared, and then at this point there is no need to simplify the numerator. We just say therefore dy x is equal to negative x squared minus 4x plus 1 divided by x squared plus 1, which has to be squared like that. Negative x squared minus 4x plus 1 divided by x squared plus 1 squared, and then it has to be squared. So let's just try to confirm. So that the x plus 2 divided by x squared plus 1, differentiate to give you 1, differentiate to give you 2x. Then v, which was x squared plus 1, we just made it x squared plus 1, then minus u was x plus 2 times 2x, well, we had 2x squared plus 4x. Dispute the negative. That's how we had negative x squared minus 4x plus a 1, and that's how we found that final answer for this particular question. Okay, so this is your final answer to question A. Now we're going to go to question B. Alright, so we have solved that particular question. Now we are proceeding to the next one. And that was question 8A. So we are going to go to question 8B. Find the equation of the normal to the curve y is equal to 5 divided by x plus a 1 at the point x equal to negative 2. This is carrying 6 marks, and it's carrying 6 marks because it is quite involving. So the equation is y is equal to 5 divided by x plus 1, and it's that's the equation of the curve, and I want us to find the equation of the normal to the curve. So to continue, we'll just write b, okay, and this would become y is equal to let me just get the complete question. 5 divided by x plus 1, x equal to negative 2. Five divided by x plus 1 at the point where x is equal to a negative 2. And then if we were to continue, y can be written as y is equal to 5 multiplied by x plus 1. This quantity raised to the power negative 1. We apply the chain rule here. Dy dx is equal to negative 5. Hope you can see that. So negative 5. So the derivative of the entire function, that is x plus 1 minus 1 minus 2, minus 1 minus 1 give you minus 2. Derivative of the core is positive 1. So dy dx would be equal to negative 5 divided by x plus a 1, the rest the power 2. So dy dx, then dy dx is a function that can help you find gradient. So it means you can say when x is equal to negative 2, our m is to find the value of m. M is equal to negative 5 divided by a negative 2 plus 1 in parentheses squared. So you're going to have a negative 5, so you say is equal to negative 5 divided by a negative 1 squared, which is just going to give you negative 1 squared is a positive 1, so 5 divided by 1, and then this will call it our gradient is equal to 5. We can say m1 is equal to 5. So our m will become m1. Why? Because we want to find the equation of the normal. So we need to start thinking of perpendicular gradients. So if we start thinking about perpendicular gradients, we know that m1 is equal to negative 1 divided by trying to find the other gradient, which is m2. So m2 is equal to negative 1 divided by m1, which is negative 1 divided by m1 is a negative 5. So m2 would be equal to 1 divided by 5, so positive 1 divided by 5. Then we would go back to the top. We would say let's not say let's say when x is equal to negative 2 in y. So you're going to have a 5, y is equal to 5 divided by negative 2 plus 1. So you have a negative 2 plus 1. Your y will be equal to a positive 5 divided by negative 2 plus 1, negative 1. Your y will give you a negative 5. Let's write that properly. Y will give you a negative 5 like that as your answer. Yeah. So here there was a negative 5. I just noticed something here. There was a negative 5 divided by a positive 1. So your answer was still a negative 5. And then there you had a m being equal to negative 5, m1 being equal to negative 5. That's why here I divided by negative 5. Take note, I thought I had made the correction, but it's like I did the correction in my head. So just like that. So y is negative 5. The coordinate therefore will be a negative 2 comma negative 5, where we're considering m2, which is a positive 1 over 5, equal to positive 1 over 5. So it means that you would have this. Let's just use the slope intercept form. Y is equal to mx plus c. Simplest method to give you what you need. Y, which is negative 5, is equal to m, which is a 1 over 5, multiplied by x, which is negative 2 plus c. So positive 1 over 5, negative 2 plus c. So you're going to have negative 5, the same as negative 25 over 5, and then you're going to have is equal to negative 2 over 5 plus c. Group like terms together, negative 25 over 5 plus 2 over 5 is equal to c. Then c would be equal to negative 23 over 5, and then therefore y would be equal to positive 1 over 5 minus 23. So this is the equation of the normal. Positive 1 over 5 x minus 23 over 5 as your final answer. Or if you want, you can expand it. Or 2y is 5y actually. 5y is equal to x minus 23 as your equation of the normal to the curve. So we need to add some. So now I'm trying to add more pages. I've seen that I've reached the end of the number of pages for this. Now it's alright, so we continue. I was just trying to add more pages. As we can see, we now have more pages here available. So let us look at the next question. So we are done with question 8. I'm going to go to question 9. Find all angles between 0 degrees and 360 degrees which satisfy the equation modulus of sine x is equal to 2x, 2 cos x rather. So between 0 and 360 degrees, this is kind 5 marks. This is question 9. So modulus of sine x is equal to 2 cosine of x. Modulus simply means we are taking into account the positive sine x is equal to 2 cos x, and then we also have the other one where we can have a sine x like that in parentheses, and then the negative is equal to 2 cos x, then not cos theta, cos x, and you divide by a negative, divide by a negative, and then you can simply say sine x is equal to negative 2 cos x as your second one. So you have your sine x is equal to positive, so the shortcut method is saying sine x is equal to positive 2 cos x, and then sine x is also equal to negative 2 cos x in this case. So we think of an identity that is easy to form. We'll just say sine x is equal to 2 cos x. We'll divide by what? Sine x. We'll divide by, or since I'm saying easy to form, let's divide by cos x. I think that one is easier to form. So you divide by cos x, you divide by cos x, cos x, cos x, leaving you with a 2. So tan x is equal to 2, x is equal to tan inverse of a positive 2, x is equal to the tan inverse of 2 in degrees is 63.4 degrees. 63.4 degrees. This is your first solution, and since here we had a positive, it means we are going to consider this solution, so it will be part of the solutions. And then we also have in the third quadrant x is equal to 180 degrees plus 63, so 180 degrees plus 63.4 degrees, and then we're going to have our x being equal to, if you add that nicely, you're going to have a 243.4 degrees, 243.4 degrees, and this is our second solution. So those are the two solutions for that particular function. So again, we say sine x is equal to negative 2 cos x. So we are dividing by cos x. Cos x, we are going to remain with negative 2, and then you're going to have tan x is equal to negative 2, x is equal to tan inverse of positive 2. So when taking the tan inverse, we disregard the negative 2. It's not necessary unless you want to use a different method. Tan inverse of positive 2 is 63.4 degrees, and then so this one will not be part of the solutions. It will just be a reference angle. I hope that's clear. So this is your reference angle there. Then you go where tan is negative, because here we had tan x is equal to negative 2, tan is negative in the second quadrant, so x is equal to 180 degrees minus 63.4 degrees. X is equal to 180 minus 63.4, 116.6 degrees, 116.6 degrees as your final answer. Then you also got the fourth quadrant. X is equal to 360 minus 63.4 degrees, like that. And then x will be equal to 360 minus 63.4 degrees, so 296.6 degrees. 296.6 degrees as a final answer. Then you can show that you know what you're doing by arranging them in ascending value. So the lowest angle that we found was 63.4 degrees, 63.4 degrees, and then next is the 116.6, 116.6 degrees. Next is 243.4, 243.4, and then 296.6 degrees. So I hope you can see that 243.4 degrees and then 296.6 degrees, and those are your marking points to get those 5 marks on that question. So that is the answer to question 9. Now we have question 10. For question 10, if you look at it, they're saying find the vector equation of a line passing through the point P, which is a 2,5, and its perpendicular vector, and so they're saying that it is perpendicular to the vector r is equal to that. So 1, 4 plus lambda multiplied by 2, negative 3, carrying 4 marks. Carrying 4 marks. So it simply means that a vector comprises of the original vector, or we can say the position vector. It comprises of a position vector there and a direction vector. So we can say here there's a position vector there, there's a direction vector. So they want you to find the vector equation of a line passing through the point that and is perpendicular to that. So when you write a vector in this form, what do you call this? This is what we call a vector equation. So the only thing that we need to know is that there. To know the vector equation, we need to know that direction vector. So this is question 10a. Question 10a. Okay. Question 10a, where we know that if we want to find the vector equation, it's xy is equal to x naught, y naught. These symbols simply mean that you get a position vector, which is just a coordinate on the x or y plane, plus lambda, okay, and then direction vector, which can be m1, m2. m1, m2, this as just simply meaning that these are the coordinates for the direction vector. Don't stress about the symbols you are seeing. And then the next thing to do will be, since they are saying it's perpendicular to this vector, it means the product of this, what we call direction vector, and the vector that is in question, they should give us 0. Product of perpendicular vectors equals 0. So 2, negative 3 times a certain direction vector should give us 0. So we have a 2, negative 3 as a direction vector here. 2, negative 3 multiplied by another certain vector xy should give us 0. We multiply across like that. I hope it's making sense. So it will be 2x minus 3y is equal to 0, where we'll have 2x is equal to 3y. We're trying to form the equation of a line. So divide by 3 like that. And then you say y is equal to 2 over 3x. Therefore, the direction vector m would be equal to the reciprocal of this. So just the number itself there. So it would be a 3, 2 without writing that division sign, because we are talking about a column vector. So direction vector is actually a 3, 2. The vector equation, therefore, passing through P, x, y, p which is a 2, 5 plus lambda 3, 2. Simple as you like, just like that. 2, 5 plus lambda 3, 2, and that will be the vector equation of that particular line. Simple as that. Don't get worried about lambda. We don't even use lambda. We don't calculate any wavelengths or anything of that nature. That's not our level. So B is the points A and B have those particular position vectors, where T is a scalar. Okay, T is a scalar. 0.28 plus 0.96 J is a unit vector. So this is a unit vector in the direction of AB. They want to find the value of T. This particular question was carrying 5 marks. So these questions on vectors, they are sometimes, okay, they are challenging, so they require you to break them down. You know, when you break something complex down, it makes more sense. So you have position vector OA equal to 5i minus 7j. So this is B. OA equal to 5i minus 7j. And then we have OB equal to what? What do we have as our OB? Our OB, TI plus 17j. TI plus 17j. So we were told that the unit vector in the direction of AB is given. So let's find what AB is, because we were given something that is in the direction, meaning it's parallel to AB. So AO will be a negative 5i plus 7j, like that, so in opposite direction, plus OB, which is TI plus 7j, TI plus actually 17j. Okay, so group like them together, equal to negative 5i plus Ti plus 7j plus 17j. So you're going to factor out the I is equal to negative 5 plus T, like that, I. Then here I'm going to have 17 plus 7, which is going to give you a 24j, because 17 plus 3 is a 20 plus a 4, 24, just like that. Then this is your AB. Negative 5 plus Ti plus 24j is a unit vector. So that is the resultant vector for those two vectors. But the unit vector in the direction of AB is this. What is a unit vector? So let's try to find the unit vector of AB first of all. So first of all, let's try to see on the question. The unit vector, let's write it. It is a negative 0.28i. Sorry, not negative. It's supposed to be 0.28i plus 0.96j. So we have 0.28i plus 0.96j. This is what we're supposed to consider when we start the working. And then the unit vector for AB is what? You have AB hat is equal to the vector itself, which is just negative 5 plus a T I plus 24j divided by the magnitude of the vector, the I component squared, negative 5 plus a T, so square root negative 5 plus a T squared plus 24 squared. So this is the actual unit vector for AB, and then the unit vector in the direction of AB is that one there. So we're going to equate AB with the expression up there. So there are various methods you can use to do this, but many of which should be time consuming. So what I would like to just do is, for example, you can just get the components having J in this case. So you have 24J, 24J, then you divide by whatever is having J. Okay, but you just get it as it is, so negative 5 plus a t squared, then plus 24 squared. So negative 5 plus a t squared plus 24 squared, square root of that, is equal to the components having J for what we have been told in the question. The components having J is 0.96. So it's equal to 0.96. What we can simply do, 0.96J. So we can drop J, and then we'll have 24 divided by the square root of this expression, negative 5 plus 8t squared plus 24 squared is equal to 0.96. You cross multiply, 0.96 root of negative 5 plus 8t squared plus 24 squared is equal to a on the top we had a 24, so it's equal to a 24. So I didn't want to deliberately distribute this negative 0. Or rather the 0.96. So 0.96 divided by like that, you're going to have a 1 like that. So you're just going to make the square root of negative 5 plus 8t squared plus 24 squared. Square root of this is going to be equal to, what is the 24 divided by 0.96? 24 divided by 0.96 will be a 25. So we're going to have is equal to 25. Now since I have the square root on one side, so we would like to square. So where the squared and square root cancel, so I have negative 5 plus t squared plus, we can simply say is equal to 25 squared minus 24 squared. So negative 5 plus 8t squared is equal to 25 squared is a 625. Then 24 squared is a 576. 576. Negative 5 plus 8t squared is equal to 625 minus 576, which is going to give you a 49. Again, you square root. You're going to have negative 5 plus 8t is equal to plus or minus square root of 49 is a 7. The first solution would be negative 5 plus t is equal to 7, or negative 5 plus t is equal to negative 7. So t is equal to 7 plus 5, t is equal to 12, or t is equal to, in this case we have a negative 7 plus 5, t is equal to a negative 2. So I found two solutions. But if we were to go back to the question, let's try to see the question. The question reads, find the value of t. When they say the value of t, it means that they are specific. They only want you to find one value of t. Now how can we know that this value of t is wrong, this value of t is incorrect? The reason why we have a number that can give us another number that can give us the answer that we have is because there was the squared. But if we were to, for example, use -2 and then we answer accordingly, for example, so we prove in the working that we made. Let's go back to the working. Where is our working? So we go to this point where we are -5 plus a t. So let's do -5 minus 2, which is -7t plus 24j. So you have -7 squared plus 24 squared, 625. Square root of answer will be a 25. Then you can also have a -5 minus t, which is we found to be -12. Is it? T in this case, t was a +12. Yeah. And went to the other side, so we found it to be +12. So -5 minus 12 give you -17 squared plus a 24. So I have a -17 squared plus 24 squared, which will give you 685. Okay, so you're going to have a 685 as your answer for the square root. So that's the mathematics we did, and then we came and concluded that t is either a +12 or t can also be a -2. So the way we can prove is just looking right here at the unit vector. So they said they are parallel. If you factor in the answers that we found, they should give us this arrow here. That is, they should give us what is in the box. Okay. So for example, you have a -5 plus t. So -5, our first t was a 12. -5 plus 12 will give you +7. Then you divide by here on the bottom. I hope you can see right here. If you want to substitute t, you are going to find your final answer as a 25. So 7 divided by a 25 is a 0.28, and then you have a 24 divided by 25, 0.96, the same. But if you have -5, then t is a -2, like that. Then you divide by a 25, you're going to have a -0.28, and then the other one, we are going to have a positive solution. So because t is giving invalid solutions, we would say t is equal to -2 is invalid. Therefore, t is equal to a what? T is equal to 12 as your final answer, and then you even get your 5 marks. Thank you so much for watching this video. This has been Cornelius Tubinda with another video, and bye bye.